All right, guys, so the exam is 28 questions. It covers Chapter 1, Chapter 2, and then Chapter 3A. And that Chapter 3A, there are about 5 questions. There is a one, well, let me go through from the beginning. So Chapter 1 includes sig figs. I think there's one question on, actually there are 2 questions. There's one where I just give you numbers and I ask you how many sig figs are in these numbers. All right. There's another question we have to do an order of operation, add or multiply or both or divide, sort of all combined like we did in class. So there are 2 of those. There are standard problems, or just do you know the standards? What is the standard for mass, length, and time? What are the properties of good standards? I think there's just one question for that. There are conversion problems. Make sure that you know how to do units that are cubed or squared. Like, I don't know, like meters per second. No, that's not a good one. Like going from cubic centimeters to cubic meters. Make sure that you know how to do that. If we need to do that today, we can do that. You have dimensional analysis, of course. There are, I think, 2 problems on dimensional analysis where I give you a series of equations and I ask you, are these dimensionally correct or not? Or I give you an equation with a variable in it and I ask you, what are the units of that variable? We've done both of those in class, but we can look at some as an example. Oh, let's see, what else is in Chapter 1? There's trig. I give you a triangle. I say, what's this angle? And what is the value of this side? There are 2 questions for that. And then, of course, that comes up in the vector problems, too. Just sort of as an aside, in my test, you probably know this because you've seen the old test, but they come in order, so the chapters aren't all jumbled up together. You'll see questions from Chapter 1, then from Chapter 2, and then from Chapter 3. They come in order. They're not jumbled up, which tends to help students a little bit, I think. Chapter 1... Unit, yeah, we did unit conversions, metric system, you need to know that. Is that all? Estimation. Oh, estimation, yeah, there are 2 for estimations. You need to know your meter, you need to know your centimeter, right, about the width of your pinky, about this. You need to take an object, like a sheet of paper or a certain object that's like in the classroom. We've done these examples, and tell me what is the area in a certain unit. It might also require that you convert units. Like, for example, if I were to ask you what is the area of this in square centimeters, it would be easier to estimate the area in square meters. It's about 2 by 3 meters, and then convert that into square centimeters. Or you could say it's 200 centimeters by 300 centimeters. However you want to do that, you're going to have to do that. Finding the area of a really well-known object, something that you will be familiar with. I think that's it for Chapter 1. Chapter 2 is kinematics. It's all kinematics. You're going to have to do graphs. I like to talk about these as qualitative and quantitative. Listen, I'm just giving you an overview now, so if you want to come back and look at some example questions from these topics, we'll certainly do that. After I'm done here in a few minutes, I'll open up for questions. Qualitative are those things like describe the motion in this graph, or give the velocity versus time graph for this position versus time graph. We've done some of those in class, and it'll help you to go back and review those. And then quantitative are those like, what distance has this object traveled between t equal 2 and 6 seconds? That sort of thing. Or what is the acceleration at t equal 5 seconds? Those types of questions where you're analyzing position versus time or velocity versus time graphs. Gosh, I think there are about 6 combined of these, 6 or 7. There's a lot of the graphing questions. That's a big part of the test. So make sure that you're up on that. The good news is that once you get it, like I think you get it. So practice this and make sure that you get it by tomorrow, okay? Because it's an important part of the test. Also, you'll see some calculation problems. Look at your OpenStats. I'm going to tell you that the calculation problems, I didn't really give you many questions. I know we had a bunch on OpenStax where you just used this basic definition of velocity. Now, I give you some more of those others that come later in the OpenStax, all right, where you're using those other equations. I just want to make sure that you're able to hold those equations, those kinematics equations, that v equals v naught plus at, and the x is v naught t plus 1/2 at squared. I want to make sure that you can use those as we move into Chapter 3, because it'll be important that you have a good mastery of those. But on those, and we can look at some of those problems, it's really about reading the problem and thinking about, what do I know? What do I need to know? You need to give some thought to, what is the acceleration in this case? Is it a negative or a positive acceleration? And looking back at some of your OpenStax or some of the examples we did in class will help you with that, and we can look at some here. So kinematics calculations, and then also we'll have some conceptual questions. Oh gosh, let's see. So look back at those concept tests, the ones in Chapter 2. I sent out the PowerPoint file. The way that I like to do it is I'll print out 6 slides to a page and then just quiz myself. Or just open it up on your phone and you can just slide through and look at the slide and say, oh, the answer is A for this reason, and then check your answer. That's a good way to check yourself. To go through those questions. Sometimes you'll see questions that are verbatim from that, so make sure that you don't miss those.
You're talking about from the online like homework?
Yeah, that's not what I was talking about, but yeah, that's true too. Let me show you what I was talking about. If you go to this site and you go to Concept Test and you go to Chapter 1, you'll download a PowerPoint file. We've done most of these in class, but some of them you did through the video, like you saw the answers on the video. But just going through these and answering these questions will be helpful to you. Some of them you'll see verbatim, actually. Like I said, you shouldn't be missing those for sure. And then some of them will be similar but different. The same material, but, different context. And then the third, Chapter 3, you will see vectors. So there were, I think, 5 or so questions from this chapter. You're going to have to add 2 vectors numerically. Actually, you know what? There were 2 questions on the test that I gave you where you have to add 2 vectors numerically. One of the question, all the vectors are on axis. You know what I mean? Like I would give you some vectors, I'll sketch it out here, where say I have a vector like this, a vector like this, and a vector like this, and I ask you what is the magnitude of the sum of those. That one's a relatively easy problem because you don't have to find the x and y components. The x and y components are already there.
Like adding up the distance they all fell together.
It's a little more complicated than that. What you have to do, what you have to do is, can I move that? I can't move that together. What you have to do is you find the resultant of those. So you find out what is this value right here by creating a triangle. We can look at some of those in just a bit, but let me just sort of finish the summarizing what's on the test. And then you have another problem. You shouldn't be surprised by this, I told you, that where you have one vector that is on axis, but look, be very, very careful that you're reading these problems because it might be over here, or the vector might be up here, in which case it'll affect your answer. And then finding the sum of those 2 vectors. Then you'll also have a question where I give you 2 vectors, like this, for example, and I ask you to take the sum or the difference of those 2 vectors. We did one of those in class, and every test has one, so make sure that you're practicing that. You will see one. I think I'll take a difference, like what is A minus B. Remember, if you're taking the difference of 2 vectors, you just flip the one that you're negating. That's all it means, that you flip it by 180 degrees. And then I think there is one question, maybe 2, that's more conceptual in nature. And looking at the concept tests, looking at the OpenStax, reviewing those, you'll see those types of questions. And I pulled some from those that are maybe a little bit different, but mostly similar. All right? There are 5 or 6 questions, I think 6, that are almost verbatim from the OpenStax. If it's a calculation problem, I change the numbers. So don't just memorize the numbers from those questions, but go back and make sure that you know how to get the answer for those questions. And if y'all want, we can look at some of the OpenStax problems. All right? All right, that's enough of me. What kind of questions are we looking at today? For you, I can pull up OpenStax and I have all the old tests we can look at.
How about like a vector?
Sure. Let me just make up one for the vector, okay? So let's say, remember I said I gave you two different vectors. Let's say two different problems. Let's say that A is equal to, I don't know, 4 along the plus x-axis, B is equal to 2 along the negative y-axis, and C is 3 along the negative x-axis. And what I want to know is, what is the sum of A plus B plus C? The way you need to do this, I like to create a little table, at least as I'm learning these, where I have the x component and the y component for each, and then A, B, and C. In one of the videos we did it this way, where we create a little table. You can do this for the others too, but in this case it helps me to think about what are my x and y components. For A, the vector A, my x component is 4, my y component is 0. For vector B, my x component is 0, the y component is -2. Be careful when you're doing this that you're aware of whether the x component is positive or negative, because depending on the angle of the vector, it could be either. And I won't say positive or negative. I don't usually say that, so you'll need to determine from the problem. And C is going to be -3 and 0. And then, if I want to know R, which is A plus B plus C, it's going to be 4 minus 3 or 1. 0 plus -2 plus 0 is -2. And so my final vector, in this case, this is almost verbatim from the test. You have a problem. I think it's like number 23 or something, 24. X is 1. Y is -2. And I want to know the magnitude of this vector. And to find that, I would say the square root of 1 squared plus 2 squared is the square root of 5, which is, 2 point something. I know that seeing it, that you say, oh, that's easy, I got it, right? But you really won't know if you got it until you sit down all by yourself, all alone, and try to do it without any help at all. And so as a study suggestion, hopefully I've been doing this sort of all along. I provide you a lot of helps, and those are good, but really need to, at this point, set yourself away from all that and just see how you do. So look in the old test, just print out an old test anew, maybe one that you haven't even seen before, and go through and try to work it, and then just see what you make. And if you make 100% or 90%, you're probably okay. Like, you could just go to bed. You should go to bed anyway. Like, don't stay up all night. But if you make a 70%, you should probably spend a little more time. Trey. Oh, yeah. I'm sorry. Yeah, so here, it doesn't affect our magnitude, but it is important. Like, if I had asked the direction, you would have gotten it wrong, right? 1 is positive, y is -2. So my resultant vector is actually down here. Is still of magnitude √5, but the angle is different. That's another thing. Make sure that you're careful about the angle, because sometimes I'll measure the angle like this, like I'll give this angle. And other times I might give this angle. I'll call it phi. If I was asking for phi, the angle from the positive x-axis is how I'd say it, the angle from the positive x-axis, then you would subtract theta from 360. It would be like 300 and something degrees. But if I was asking for theta, I would say the angle below the negative x-axis. Look for those words when you're working problems. You'll see what I mean. Okay? This one? Okay, good problem. Let's see. So I want to start. I'm just going to write down what I know. This is number 21 on fall 14, right, Morgan? Okay, it's not in your workbook, unfortunately. But if you want to, you can just sketch down fall 14, number 21. I think I only have fall 15 in that workbook. All right, so a truck covers 100 meters. That's my x value. In 10 seconds, at which time I just sort of let out a sigh because I know if I have the time, the problem becomes a lot simpler. While smoothly slowing down to a stop, what is its initial velocity? Now, this is where I need to think about it. I know x equals v naught. That's what I'm looking for, the initial velocity. And since it's slowing down to a stop, that tells me that v is equal to 0. Right, this truck's chugging along, and then it starts to slow down, and after 10 seconds it stops. And so I want to know what is the initial velocity before that 10 seconds, but I know at the end of the 10 seconds, then v is going to equal 0. And so those weren't given in the problem, but it's something that you need to infer from the problem. All right, so let's just, I know if I'm looking for x, I got to use this, v naught t plus 1/2 at squared. Oh goodness, what am I missing here? I'm missing a and I'm missing v naught. And then in which case I say, well, I can't answer that. So let's write down my other equation, v equals v naught plus at. Well, I don't know v naught, but I don't know a either. Okay, so listen, this problem requires you to substitute one equation into another. That's why you're asking it, aren't you?
I watched like how to do it. I just want to see you do it like in person.
Okay. I'm not going to give you a problem where you have to substitute one equation into another. Do you want me to finish it?
No, you don't have to. It's fine.
I'll finish it. It's not a terribly difficult problem. 0, I know you watch it. You know how to do it. V naught plus a times 10. And so what do I do here? Yeah, a is equal to negative v naught over 10. And then you would take this and you would substitute it in right here. Solving a system of equations. You should know how to solve a system of equations, right? Like you've had this in college algebra, I know you have. But in this class, for the exam, I found that it just takes too long to solve a system of equations for a 28-question test in an hour. So that's why I don't require it. And often you just sort of make a simple mistake and you get it wrong. So I don't require that kind of algebra on the test. Anyway, once you go from here, then you have an equation with just one unknown, and you would solve that for that unknown. Okay? You understand what I'm saying? You're not going to have to do that kind of algebra. You only have equations with one unknown in them as you move through the problems. But it's still a good problem because you have to think about, what are the variables that we're working with. William?
Referring to workbook. So how do you figure out positive and negative values if it says that the vectors are above and below?
Good question. Morgan, is that Anna for this one?
Yes.
Okay. Let me show you. So, how do I know if it's above or like positive or negative? Let's say if I give you a vector and I tell you that it's 30 degrees above the negative x-axis. Let's say this is 2 meters, and I would tell you in words that this is 2 meters at 30 degrees above the negative x-axis. Now, when I do the components, this would be 2 cosine 30, and this would be 2 sine 30. Notice that this component is going to be negative because it's pointing along the x-axis, the negative x-axis, but the other one's going to be positive. It always helps to draw your vectors. Take that extra 15 seconds to draw out the coordinate system and then draw the vectors. That's how you know. All right, what else, y'all? William, that's okay?
A problem that deals with it like the one on page 58.
I don't have that right in front of me. Yeah, Courtney.
I have a question. The vector problems, they were on like a good bit of it last couple of tests.
Normally the last question about the appropriate angle,
Uh-huh.
like finding the appropriate angle for the vector when given only a positive and a negative y component. Like, you know, figuring out which quadrant.
Like this one?
Yeah, you can narrow it down to 2 normally just by looking at the quadrant, but how do you figure out?
Okay. Yeah, William, we'll come back. Let me answer this. We'll come back. We'll look for a vector problem. But I want to look at some of the other topics that we're having on the test. But yeah, so with this, and you can see something like this, just describing and thinking about how are the components and the vector related to one another. Can you rephrase your question? Tell me again what you're looking for.
How to narrow it down. You can normally narrow it down to 2.
Oh, yeah. Okay.
How to figure out which one it is.
So on this one, I'll draw my vector. It says the magnitude of the y component is bigger than the x component, and it has a negative x component and a positive y component. Now, the negative x component tells me it's going to be over here, and the positive y component over here. So it's somewhere in that second quadrant, right? I know it's in the second quadrant, which gets rid of this, it gets rid of this, it gets rid of this. I narrow it down to 100 or 150. Now, the next key is looking at which is bigger. The y component is bigger than the x component. So let's just do a sketch. There's my x component. There's my y component. So the resultant vector looks like that. Now notice, this is 90 degrees. This is 180 degrees. Let me show you something else that's going to blow you away. This angle is 135 degrees because it bisects that angle, right? It's 45 degrees. And so I know that it has to be between 90 and 135, which gives me 100. You follow?
Yeah.
How do you get the 135?
Because this angle right here is 90 degrees, and when I bisect this angle, I have two 45-degree angles. So this angle right here, from here all the way over to here, is 90 plus 45, which is 135. All right? Good question. You certainly have a conceptual question where you have to think about the components and think about how the angles are related to the size of the components, those sorts of things. This is a good example of that. 25 is a good example of adding two vectors that are not on axis. That's what you were asking about, right, William? Yeah, this is similar. So you will have one of these tomorrow for sure. On these, you follow several steps. So first, you find the x and y components, ax, ay. I'm looking at 25. This is, anybody know what exam this is? It's fall 17. 25 on exam 1, fall 17. AX is 2 units along the negative y-axis, so that's equal to 0. AY is negative 2. Let's draw that vector. AX, our A is right there, and then B is 9 units at 60 degrees above the x-axis. That's A. This is B. It's 60 degrees, and it's 9 units. This is 2 units, not drawing a scale, obviously. Then BX is equal to 9 cosine 60. Notice it's positive because the component of this vector lies along this axis. And then BY is 9 sine of 60. Notice it's also positive because it's along this axis. And so this is 7.8, and this is 4.5 for bx and by. Now I'm looking for the sum of these two vectors. So I'm looking for rx and ry. Those will be the components of the sum. It's going to be ax plus bx, 0 plus 4.5. And ay plus by, negative 2 plus 7.8. those give me the components of the new vector. And so that new vector will have a component 4.5 units, 5.8 units, and then I'm looking for the magnitude and the direction of that resultant vector. Do I need to do that? Are we okay with that? All right, we can come back to it if we need to. But what other questions are we? Madam, what's up?
Number 11 on this test.
Yeah.
Can you use one of the equations for acceleration? You put in -10 meters per second squared. Like to find time first. On v equals v0 plus at.
Number 11. Okay, that's the acceleration due to gravity.
Okay, so you're just adding some.
Yeah, I just use 10. It's easier to use that number. But look, you will have this problem. I could ask you several things about it. I could ask you, how long does it take to go up and then come back down again? How long does it take just to go up? How high does it go, like it does here? Those are probably the only questions I could ask you, but you will have a question like that.
You said it loses a second for each.
Yeah,
It goes up.
if you're accelerating at minus 10 meters per second squared, as it's going up, you lose 10 meters per second. That's what that means, right? 10 meters per second squared. So if you start out at 30 meters per second, then it takes you 3 seconds to go up. It goes from 30 to 20 meters per second to 10 and then to 0. That's 3 seconds. It goes to 20, 10, and then 0. And then back down again, it increases at the same rate. But in this case, I'd first have to find the time. V is V0 plus AT. At the top, goes up, comes back down again. V is equal to 0. 0 is equal to V0, which is 30, minus 10 times t. And solving that for t is negative 30 over negative 10, which is 3 seconds. That's my time. But I'm looking for the height. If I was looking for the total time in air, it'd be what? 6 seconds. So I'm not looking for that, though. I'm looking for the height. V0 t plus 1/2 AT squared. And up here, I know now that t is equal to 3 seconds. I just found that. So this is going to be 30 times 3 minus 5. That's half a negative 10 times 3 squared. 90 minus 45, 50 meters. Okay? We've done this problem before, but you'll see it tomorrow. Something very, very similar. Different numbers, of course, but very, very similar. I want you to definitely get that one. Should not miss that one. It's important for chapter 3.
Trying to write the whole thing down.
Oh yeah, I know it. So that's equal to 45 meters. All right.
You think number 8?
Yeah.
Would you just do the 8? You'd have to add 180 to the. Okay.
Yeah. So number 8, it's a good question because it helps you to think about the language, because I'm looking for a measure from the x-axis, which would be this angle. But listen, some of your calculators are smart enough for you to put in a negative x component and a negative y component, and it'll spit out the right angle. But many of your calculators are not smart enough. Like if I do the inverse tan of, what would it be, negative 2 over negative 5, what was the answer here? What is that?
Well, it's 22 is the angle, but the whole answer.
Okay, yes, some of your calculators will put out 22 degrees, and then others of your calculator will put out 202 degrees. You see the difference? And some of your calculators will read this and they'll say, oh, what's the inverse tan of positive 0.4? And some of your calculators will say, what's the inverse tan of the negative x component and the negative y component and the negative x component. Most of your TIs will just spit out 22. What did yours spit out? Yeah. Okay? So it's always good to draw a picture. And in this case, you would find that this angle is 22 degrees, and then you would add 180 to it to get the answer, which is 202, or 200 degrees with proper sig figs. But in this case, I mean, you could just look at this, right, and know that the answer is B, because 250 degrees is really the only other possible answer, but 250 degrees would be down here somewhere, and that's not what that line is. It would be past that halfway point in that quadrant, which is at 225, 180 plus 45. This first test, there's a lot of sort of catching up with high school math. A lot of your trig and your geometry, and you're just dealing with the angles and the quadrants, but it's important as we move into chapters 3 and 4 and 5 and 6 and 7 and the second semester. All this stuff we keep on doing. It's exciting, right?
No, it's not. You have a very different definition of exciting.
What else? I think it's a good definition of exciting. Because when you learn how to do it, it's just like, wow, it's like Sudoku. It's like a little puzzle that you're trying to put together. Who likes puzzle? Who likes Sudoku? Yeah, and who likes physics? Yeah. All right? It's the same. It's the same. All right, what's the next question? Yeah, of course. Give me just a second to pull it up. Make sure I don't show any of your scores. I don't think that. Does it tell you hi when you log on to OpenStax? No?
I think it, you know what he said.
All right, which one do you want to look at? You want me to sort of pull them up and we'll...
Can we do the one with the sharp, the area under the...
That was chapter 2, right?
Yeah, that was the first.
That's one.
Or it was something.
Yeah.
Okay, give me just a minute. Give me just a minute. Is this the one?
No, the one,
The shark one?
find the area under the...
The, this one? Okay, so here I wanted to know the total distance, and you will absolutely have to do some problems like this, where I'll give you a graph and I'll give you both a position versus time graph, and I'll give you a velocity versus time graph, and then there are several questions that follow out of that graph. And you'll have to tell me things like, what is the instantaneous velocity or acceleration? One of those graphs is going to be a squiggly line, and one of them is going to be straight lines. It'll be linear, or at least linear in parts. So you'll need to be able to find a tangent line like we've done, where it's a squiggly line, and then you'll need to be able to just find the slope of a straight line. In this case, we're looking for the distance traveled between, was it 0 and 10 seconds, do y'all remember? Yeah, so if I find the distance traveled, I find the area. Oh, will this let me write on here? It will not. Oh, there we go. All right, so if I find the distance, I have to find the area. I'd find the area of this part, half base times height. Make sure that you look at the units on the axis. I try not to give the same tick marks on both axes, so that if you count the squares, you'll get the wrong answer. Like I do that on purpose. You understand? So don't count the squares. Look at the axes. Half base times height will be a half of 4 times 12. That's equal to 24. But then you also have to add in this area, which is 6 times 12, which is 72. So that's 96 meters. Okay? Also in that OpenStax, this was a good quiz. I like this one. You have to do the instantaneous velocity here. Where is that one? the shark problem. Here it is. Look, I like this one because I liked it. They asked what is the total distance and what is the displacement. I think it was between 0 and 7 meters. And in that case, what you had to do is, well, you know the displacement is 0 because I'm starting here and I'm going back to here, right? But then you think about the distance traveled. The net displacement is 0, so that gets rid of this one. And I don't think about the distance. Well, I go here from 0 to 20, so I travel 20 kilometers. And then I go 20 to 10, so I travel another 30. And then the shark just stays still. I didn't know sharks could do this. Can they stay still? I thought they died if they stayed still.
They don't.
That's a
Depends on
myth?
species. It's depending on what species. If it's like an angel shark, then yeah, you can totally.
Well,
Any other type, any other type, yeah, you're.
okay, well maybe this is an angel shark then. But
Since it's negative, it might be referring to it might just be referring to depth instead of.
could be death.
I'm just gonna assume depth because negative.
Maybe so. Anyway, so here it travels 10 kilometers. So my total distance would be 20 plus 30 plus 10. So here you weren't finding the area or the slope. You were just looking at the numbers on the graph. Do you see me? I'm trying to wink. That means that you're going to have a problem like that. Did you get that? Do you see me winking? See? It's a wink. All right. What else? OpenStack. You want me to scroll through some of these? Or, did you want me to wink on the ones like pause and wink? I just did that. I did tell y'all that like some of these kinematics problems, they're really just using that. Where is it? Where they're just using the velocity as distance over time.
Yeah, I was the swimming one. Yeah.
Okay, so he swims 3 laps in the pool, 105 seconds. If each lap is 50 meters, what is his average swimming speed? Yeah, you need to know this, but it's not really going to be explicitly on the test, these type problems. I've already told you that. The total distance here is 150 meters. You divide it by the time, which is 105 seconds, and that gives you 1.4 meters per second. All right? Your kinematics problems will be more like the ones that come later in this quiz. Let's look at those. I keep calling it a quiz. This homework assignment.
That.
No, something like number 19. Number.
You
want me to do number 19? Okay. Something like number 19. Okay, so this one was actually fairly straightforward because, well, it gives you the sign of the acceleration. I'm never going to do that. Like, you'll need to think about, well, what's it doing? Is it slowing down or speeding up? And what is the sign of the acceleration? So he's traveling with an initial speed of 9 meters per second. The acceleration, he's slowing down, so his acceleration is opposite the velocity at 3 meters per second squared. And I want to know the time required for him to come to a complete stop. So that means that v is equal to 0. So you probably recognize now that I'll need to use this. V equals v0 plus at. And solve that for t. 0 equals 9 minus 3 times t. Well, t is equal to 3 seconds. Okay? These are similar questions. Number 20?
Yes.
All these are pretty similar, so I would certainly go back and look at those, especially those last 4 or 5 in this quiz. Okay. So here, I have a rock or whatever, and it drops down 30 meters, you have to recognize that this initial position is 0. That always, in this class, we always allow our initial position at t equals 0 to be 0. That's why we never get that x naught in that x equation, because it's always 0. But when I have that, that means that x final is going to equal to negative 30. So it's given us 30 meters, but it's actually negative 30. So I need to remember that x is equal to negative 30. V naught is 0, because you know you're dropping it. Initially you're just holding it, and then you let it go. Oh wait, no. This one was, you did not drop it, because you're looking for the initial velocity. So you're actually sort of throwing it down a little bit. So I don't know what V naught is. I know that it takes 2 seconds, and I know the acceleration is minus 9.8. We would say 10, minus 10. So I want to know what V naught is. I'm sorry, I messed this up. V naught is not 0. I need to know V naught. I don't know VF either, by the way. But they're not asking for that, so I'm just going to cancel it out. Okay, so let's just write our equations over here. X is equal to V naught t. It's 1/2 AT squared. Ask myself, what do I know in this? Or what do I not know? I don't know V naught. Oh, look, I know everything else. So that's just, I stop right there. This is how I'm going to solve it. I'll say that X is minus 30 equals V naught times t, which is 2, minus 4.9, that's half of 9.8, times 2 squared. And solving that for V naught should give me minus 5.2. Yeah.
Well, we can test for gravity. Do you want us to use 10 or not?
I want you to use 10. Yes. If you use 9.8, you'll get an answer that's really close to what's on there, but it won't be exactly the same. I try not to give answers that are so close that rounding won't, it shouldn't affect it if it's rounding. All right? What else? Can I say something? I'm talking to people that are listening too, like if you're watching online. When you bubble your form, you listening? Make sure that you get your N number right. And being right means that you have the right numbers, right? You're using the right numbers for your number, and then also that you put the numbers in the right order. Like that's an important thing, that not only that you use the right digits, but that you put them in the right order. Otherwise, it's somebody else's N number, okay? It's a lot of trouble for me when students don't do their N number correctly. I know it's just, like you're not doing it on purpose. Like it's not like you're vandalizing your N number, but it still makes a lot of trouble. So if you just take an extra second to review your N number before you come in, you can even write it like on your hand, but don't write anything else on your hand, okay? There's not much you could write on your hand to help you anyway. But if you need to write down your N number on a slip of paper beforehand, that's fine. Okay? Can y'all do that for me? Like I would love your N number. You need your N number. Okay? What else for the test? Yeah, Madeline?
Quick little review of describing the motion.
Yeah, good question. You have a related question, Russ?
No, I was just gonna ask you how much chapter homework.
Okay, we can take a look at it. Let's review motion because we haven't really done that much. But I want to remind you that, yeah, William, you have a related question? I solved for that.
I could not understand the work.
Do you want me to show you my one?
I cannot. I'll do it quickly. Okay, I'll do it. It's okay. Let me just. So what I do here is I say minus 30 plus 4.9 times 4, whatever that is, and then I divide that whole thing by 2, and that should be equal to minus 5.2. I take this and bring it over to this side, and then I divide by that 2 to isolate the V naught. We can look at it later if you want. Let's do this. We're almost out of time, so let me go over these. It's an important part. You have several problems, I think, that are qualitative in nature. I think I can think of at least 3 that are on the test. The slope of this first graph is equal to the velocity. Here, the slope is equal to the acceleration, and the area is equal to the distance. So you want to be able to look at a graph and describe the motion. And by doing that, you ask yourself 2 questions. What is the sign of the slope? And what is the speed? How is the speed changing? And the sign of the slope in this case, you know, positive slope. This is actually a negative slope. This is a positive slope. So over here, my slope is negative. All right, so in this first one, I have a negative slope. And at first, I have a big negative slope. And then down here, I have a small negative slope. That means that this object is traveling left or right. You know, it's not a joke. Is it traveling left or right? It's traveling to the left because the position or the velocity is negative. Negative velocity does not mean it's slowing down. Negative velocity does not mean anything about how the velocity is changing. It just means it's in the negative direction. So it's either to the left or it's down, right? That's what the negative slope means. And then the changing speed, that says something about the acceleration. So this object is, the speed is decreasing. And if it's decreasing, that means that the velocity and the acceleration are opposite. They're opposite directions. So since I have a negative velocity, that means in this case I have a positive acceleration. Even though it's slowing down. So this object is slowing down, but it has a positive acceleration. Okay? Now, I also want to be able to translate this graph over into V versus T. You might have a question like that where I give you a position versus time and I ask you to show me which V versus T is the correct one. Well, down here I have my negative velocities. Up here I have my positive velocities. Just try putting in some numbers. Say this is 0, this is negative 10, this is positive 10. Where am I going to start? I have big negative velocity over here. Where am I going to be? In the first or fourth quadrant? The fourth quadrant. Am I going to be up here close to the origin or down here? Down there, right. Down where it's big and negative. So this graph would look like this. It would start right here. That's this point. And then it would get smaller, but still negative. Like that. All right? You should also be able to, you've all done this lab if you're in the lab, most of you are, to be able to take a physical scenario like the drop, the pass, and the bounce pass, like I did with the basketballs, and draw or identify the graph for each of those. So for example, the drop, the V versus T graph looks like this, right? Notice that the slope of that line is negative, which is the acceleration. The acceleration is negative. The bounce pass, that's where you take a ball and you drop it like that and it bounces up. The V versus T, oh, what is this one? Looks like that, right. Where you have that discontinuity at the bounce. And then just the pass. That's where you're just throwing a ball like this. Looks like that. The V versus T. Where this is the top of the trajectory. This will come up. Actually, this is more like next chapter. Yeah, you see some of this in the concept text. Who asked that? Madeline, did you ask that? About the graphs?
Yeah.
Does that help you some? William?
What would happen if one in a given graph, if one of the slopes is positive while another is negative? What would happen then?
What can you explain a little more?
Like if a graph showed a positive slope on at one point and then it turns into a negative slope, what would the overall
Yeah, you can have that, right? I mean, say I had a position versus time, x versus t, and it looks like this. Is that what you mean? Like here? Here I have a positive slope. Here I have a negative slope. That's just like, Morgan, you ready? That's that, right? And throw it back to me. Because it goes up, and initially it has a big positive velocity. At the top it has a zero velocity, and then it comes back down, and it has a big negative velocity. That's also if I do this. If I just throw it straight up.
So what about zero acceleration?
Zero acceleration. If I have an object with zero acceleration, good question. It would look like this. So if A is equal to 0, the position versus time graph could look like that. It would just have a straight line. That straight line could be any direction. It could look like this. It could look like this. It's just going to be a straight line so that the velocity is not changing. If I draw the V versus T for 0 acceleration, this one's a little more specific. What's it going to look like? Just straight across, right, with 0 slope. It has to look like that. But the 0 acceleration of the position versus time graph just means that the velocity is not changing. Actually, it can't be this one, right, because this one just means that the object. Oh, no, it can't be this one. But it could be any of these others.
That would make velocity.
Huh?
That would make the velocity 0.
Yeah, in this one, the velocity would be 0. And if it's maintained to be the velocity equals 0, then the acceleration would also equal 0. But as you know, you can have 0 velocity, or 0 velocity and non-zero acceleration, at least for an instant in time. That's where we had this, where at the top of the trajectory, it was still accelerating, mainly because the object is turning around. That's the acceleration. But it has 0 velocity. It stops up there just for an instant, but it still has acceleration. Friend?
So you said that if speed is decreasing, then velocity and acceleration are opposite.
Right. If an object is slowing down, right, is that dance. That means that velocity and acceleration are opposite.
What if it's
It means they're in the same direction. They can either be in the positive or the negative direction. All right. We're running out of time. Any last-minute questions, William?
So back to that hill graph, what would the overall slope be?
The overall slope of this graph, well, the slope changes. It's positive here, it's 0 here, and it's negative here.
So what would the overall slope be?
There is no overall slope. The slope changes with time.
So it would be just constant?
No, it changes. Like, let's say it's positive 5 here, positive 3, 0, negative 3, negative 5. Ross?
Ask me homework, chapter 3 homework.
We're out of time, but we can hang out. And if anybody else has other questions, I can answer them afterwards. Y'all are welcome to go. It's 4 o'clock. You don't have to stay any longer. But if you didn't see me beforehand, if you don't think I wrote your name down, then please come see me now. Okay? Will velocity and acceleration ever be negative at the same time? Sure. watch this. Right, in that second part of the trajectory, it was moving down, and it was also accelerating downward. So when you have a negative velocity and it's speeding up, that's when velocity and acceleration are both negative. All right? Okay. Yeah, yeah. You can have, like, can you have position be 0 and speed be not 0? Yeah. Watch this. This is position equal to 0, right? Well, did it stop when it came to position equals 0? Right.
So you can have a position 0 and speed not equal.
Right.
Velocity, and that speed and velocity stay the same. Like if position 0 have a velocity that's non-zero.
That's right.
And if position 0 has a velocity that's non-zero.
Yeah. All right. Courtney, what is it?
It's okay, you said it like 3 times already, but if something's slowing down, velocity and acceleration are opposite.
Right. If something's slowing down, velocity and acceleration are opposite.
And if they're speeding up,
They're in the same direction. They could be both negative or they could be both positive.
On the 2010 test, there's like a concept question and it says you drop 2 rocks.
Hold on. Ross, you had questions, right? You want to hang around?
Yeah, about the whole, like,
Okay, let me, yeah. We'll take a look at
You
it.
dropped 1 rock and then like 4 seconds later you dropped another rock.
Uh-huh.
And it asks about the distance between the 2 rocks.
Yeah.
We thought it would be the same, but it said it was.
Yeah, don't worry, you won't. Is that okay if I just tell you? 'Cause I try not to pick, those are kind of tricky.
Yeah.
And since we didn't go over it in class, I didn't put it on the test.
Okay. Because I knew that the acceleration was the same, but
Right. It has to do with the fact that v0 is not 0. That if you look at that function, then x will increase more because v0 is not 0. But don't sweat it. Okay? Okay? 28 questions. No, send me an email. I'll get you set up, okay? Do it today, though, okay?
What would the scenario be if velocity equals 0?
If velocity equals...
Rapid scenario.
Okay, so if I had velocity equal to 0, what that would look like in a position versus time graph, it would look like that. In a v versus t graph, if I had a v versus t graph, velocity equal to 0, it would look like this. Right? The line would be along v equals 0. All right. You want to look at Chapter 3, OpenStax?
yes.
Okay. Do you have a question, Kate? You're welcome to hang around. Oh, did you get your name? Okay. Okay, I appreciate that. All right. Chapter 3, you said, right, Ross? These numbers aren't right, so don't. The questions are the same. All right. So I'm going to scroll through and you holler out, okay, if you see one that you want to look at in particular.
That one,
All right. Let's do it, but I'm going to I'm going to rewrite it just a little bit. Where the angle is measured. So I'm going to rewrite it just a little bit. Instead of 37 degrees right here, I'm going to write 53 degrees south of east. Now you will see no cardinal directions on the exam. You're only going to see angles from the x or y x-axes, positive or negative x-axes. So 53 degrees south of east is the same as 53 degrees below the negative x. So that's how you would see it, but otherwise it's the same problem that you'll see tomorrow. And then also actually instead of south, I would say along the negative y-axis. And when I do that, it's a fine problem for tomorrow's test.
My question is, do you draw the second, no, I forgot the word.
Do you draw it tip to tail?
Yes, that.
You can if you want, but by this time, like, y'all know how to do tip to tail, so I don't usually do it. I just like to draw the two vectors from the origin.
That's what.
So if a vector is below the negative x-axis, that means the y-coordinate would be -2.
Yeah, let me show you. So the first vector is along the negative y. It's 2 kilometers. The second vector is 53 degrees below the negative x-axis. So that's 53 degrees, and it's 1.5 kilometers. So that's what that vector would look like, 53 degrees below the negative x-axis.
It says here, like, it says it's supposed to be like connect, like it's gonna be the tip of the
Yeah, if you wanted, like, if you really want to do tail to tip, you could take this vector.
Well, that's what the tutor said. His name is Brock.
Oh yeah, Brock.
He told me to do that, and he kind of accidentally misled me into like clicking 0.5 and doing like the Pythagorean theorem.
Yeah, I put 0.5 on my answer too.
But look, I mean, if I draw it tail to tip, I'm looking for this vector. I know that's not 0.5 meters.
Okay, so how would you find that?
No, okay.
So how would you find it?
How do you find it? Okay, so I have this. I'm sorry.
That's what I want to see, like done like this.
You want me to just leave it like this?
Yeah.
Okay.
I drew it tail to tail, but I didn't know how to figure it
All
out.
right, let's call this vector A, and we'll call this vector B. AX equals 0. AY equals -2. It's negative because it's along the negative y-axis. And BX is 1.5 sine, not sine, 1.5 cosine of 53. It's going to still be positive because it's along the positive x-axis.
Dy is 1.5 sine 53.
Right. This is 0.9. Be careful though. By is actually equal to negative 1.5 sine of 53. Which is 1.2. So it's negative 1.2. That By is negative because the y component lies along this axis. This is in that fourth quadrant. It's along this axis. Yeah, if it was in the third quadrant, y would still be negative. That's why it's so useful to draw your vectors. Then you add up the x components. You add ax and bx. So rx, which is going to be the sum of these, is going to be 0.9. And then ry is the sum of these two, which is minus 3.2. Which again, is if we go back to how we drew this, this isn't exactly to scale, but if I draw it tail to tip, yeah, that vector, I would say.
That's very good illustration.
Mine came out like that even without the -2.
Had the same numbers.
Then when you do the Pythagorean theorem there,
Yeah.
I'll read it. And she had me draw like this.
That's fine, it came out okay. But if I'd asked you for an angle, you really got the wrong answer. So you were just drawing it up in the first quadrant instead of the third. Or the way that you were calculating the numbers, you're doing it in the first quadrant. Because you made both AY and BY positive, right? Yeah. So you're either doing -2 minus 1.2 or 2 plus 1.2, and they both give you the same y component of r. So you got the right answer. But if I had asked you for the angle,
Well, I evidently never used, well, I would have known that I was in quadrant 4.
yeah,
That's tangent, so I would have known that that's supposed to be.
hopefully. Okay, good.
So I would have known, if you look back, that I would have done something.
Right. Okay, yeah. You got to be careful. It's kind of, you got to be very careful at every step along the way.
Are we gonna have
Yeah. Mm-hmm.
Okay, so
Yeah.
So the drawing is wrong.
So here you do Pythagorean theorem, like I said, is 0.9 squared plus negative 3.2 squared, but the negative goes away, and that gives me 3.3 kilometers.
So without
number 5 is the question. Number 5, and other than that, the only other question I have is number 5.
Okay, let's take a look. Oh, number 5 is very similar to number 3, though. Like if you can do number 3, number 5 is practically the same. Yeah. Except I would give you the cardinal directions. I wouldn't give you cardinal directions. There's no west, north, south, east on the test. It's all measured from the positive or the negative x-axis. Okay?
A,
Okay?
Okay.
I'm gonna go ahead and stop the video.